Hello guys, welcome to the course of Computer Organization and Architecture. In today's lecture, we will talking about what is sign representation. Already we have discussed what is unsigned representation in our last topic. Let's see an example of 5. So, how can you represent this 5 into a binary in unsigned representation? It is basically 101 as a binary. Suppose someone asks you just represent plus 5 or minus 5 into binary. So you cannot represent a plus 5 or minus 5 these sign numbers into binary with the help of unsigned representation. So you have to choose another path. So there are two forms where you can use that two forms to convert this number into a binary. So these are basically a part of sign representation. So they basically their two forms are sign magnitude form and another one is a complement form. So where complement form further classified as one is complement and two is complement. So first let's first understand the basic things. What are the basic things? The basic term. The first term is that LSB, that is sorry the MSB, the most significant bit, and another term is LSB, that is significant bit. So here what is bit here? So bit is nothing but it is the smallest unit of data in a computer and where it is a single binary digit. Okay, so these are the basically two possible states, that is 0 and 1. So here you can see that these are the bits. Okay, and now let's discuss about MSB. So in a binary number of nth binary number, in the leftmost side, the last bit is basically the MSB, your sign bit, which is used to represent your sign. And these bits, these are the basically n minus 1 bits, which is okay. So these are the magnitude bits. These are used to represent magnitude, and this nth bit is your sign bit. Okay, so depend on that value 0 or 1, it gives you positive or negative sign. Okay, so this is your MSB, that is the sign bit. And now this is a 7 bit binary number. So here 6 bit is reserved for magnitude and the 7th bit is reserved for sign. So this is your MSB. Now let's understand what is LSB. So here you understand that the leftmost significant bit, sorry, the leftmost bit, the last bit is your MSB, and the first bit from beginning from right hand side, the rightmost bit is your LSB, that is least significant bit. There is no any role of LSB in sign. Okay, so because there is only one bit is reserved for sign, that is MSB in sign bit, and the remaining bits are basically used for magnitude, and LSB is a part of magnitude. Now how MSB decides a number is positive or negative. So, in a binary number, if the MSB, we can say that the sign bit is 0, then it is a positive number. So, it is indicates that it is a positive number. And same way, the sign bit is 1. That means that this number is a negative number. Okay, so this is all about the MSB and the LSB. Now let's understand by an example. Then how can you represent this plus 5 into a binary with the help of sign representation? So here you can see that there is a positive sign, a sign bit, and the magnitude is 5. So plus 5. So here plus is basically your sign bit. So what will you do? Just write the bits. Okay, so the first one is that the magnitude of 5 is 101 and the remaining extra bit is used to for the sign. Okay, so here the one extra bit is used for sign. So here the one extra bit is 0, which is basically positive sign. For positive sign we have to write a 0. Okay, so this is your MSB and these are the remaining bits. So this is basically a 4-bit format of plus 5. So this 4-bit format, a bit format, as given to the question. Okay, so this will be given in your question already. So suppose that you want to represent minus 5 into binary, so what will you do? Just write the binary form in same way. So here just change that value of MSB because due to of negative sign. So here sign is negative. That means that MSB should be 1. So this is your MSB, and we can say that this is a 4-bit representation of minus 5. And the same way, if a question asks as that represent minus 5 in 8-bit format, so how can you represent it? So first of all, just write the 8-bit and put 1 for the MSB because due to negative sign. So MSB is 1, and here 5. 5 is 101. The magnitude of 5 is 101. Just write down the magnitude and the remaining parts, the put 0 for the remaining parts. So this is basically your 8-bit format of minus 5. Okay, so in this way you can represent a minus 5 into 8-bit format. So here the bit format, the number of bit formats should be given in your question. Okay, and now let's understand this question. What is basically this question? So this is one of the most important question from this topic. Generally students confuse in this part. Suppose if you want to, so what is the equivalent of 111 in a decimal? So basically this binary number converting to decimal as 15. So our answer may be 15, but it is not a right answer. Why? Because there is a constraint here that equivalent of this number in sign bit magnitude form. So what will we do in sign bit magnitude form? So you just write the number as in this way. So since it is a sign bit magnitude form, that must a 1 bit, that is your MSB, should be reserved for your sign. Okay, so here that bit is reserved for your signature, sorry, the positive sign or the negative sign maybe. Okay, so here that last bit is reserved for sign, that sign bit, because this is a sign bit. And now the remaining bits are used to represent the magnitude. So here the 3 bits are basically represent magnitude. So how can it represent? So just write down the magnitude. So what is the weight of the each bit? That is 2 to the power 0, 2 to the power 1, and 2 to the power 2. These are the basically weights. And for 1, since the MSB, that sign bit is 1, so it is a negative number, that is negative. And now the equivalent of magnitude is as 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0 as multiplied by 1, and that is 4 plus 2 plus 1, which is equivalent to 7. And now the equivalent binary form of this number is minus 7. So the correct answer is minus 7, not 15. If a sign bit is not given here, then 15 will be the correct answer, but the here correct answer is minus 7. And now this is the end of this lecture. If you like the video on computer organization and architecture, so please do subscribe the channel. And thanks for listening, and God bless you all.